Welcome to At Home at APS, and we're so glad that you're here with us today. My name is Ms. Karnes, and I work in our school district, and I love to teach kids and teachers about new, exciting, and fun ways to think about and understand math. And so that's what we're going to be doing here today with a team of my teacher friends to help me. So what I'm going to do is we're going to start by looking at some patterns that are going to get you thinking about using what you know about numbers and groups of numbers to figure out how many in all, and hopefully in an efficient way, a way that's easy for you to see and to know. So first, let's look at something pretty familiar, guys. So kiddos, what do you know about this pattern? It's 5, isn't it? This is the pattern for 5. And how do we know this is 5? Maybe you counted it really fast by ones. Or maybe you knew that 1, 2, 3, 4, and one more would give you 5. Or maybe you saw 3 and 2 more, and you knew that was 5. Or maybe you just saw this pattern and said, this is the pattern for 5. And I just know that because I've seen this pattern on dice and on dominoes and in lots of other places. So there's lots of ways to know this is 5, and the important thing to know about this pattern is when it looks like this, it always is 5. So we're going to think some more about 5. Let's look at some patterns that have more than one 5. Right. Take a look at this dot pattern. What do you notice about it? What do you know? How many dots are there? Oh, you think 20? I hear some of my TV friends saying 20. I think you could be right. How could we know there's 20? So we could count them by ones, right? That would be one way to know for sure. Maybe you thought about our pattern for 5s and you decided to count by 5s. Let's go ahead and try that together. So 5, 10, 15, 20. So it looks like we were accurate. There are 20 dots here in our 4-5 pattern. So we could count by ones to figure out how many there are, or we could skip count by 5s to sort that out. Can we show what our skip counting looks like with a number sentence? I think we could. Let's try. Oh, actually, we're going to save that for later. Miss Karnes forgot. What's another way to know that there's 20? Do you see some other patterns here in our group of 4-5s? Maybe you thought about, if I put 2 5s together, that makes a 10. And 10 and 10 also gives me 20. So we can skip count by 5s. We can also combine our groups of 5s together to make larger groups of 10 and count by 10s to know that there's 20. Are you ready to look at another pattern with even more 5s? Take a few minutes to look at this one, and I want you to think about, what do your eyes see first? What does your brain think first? How many dots do you think there are? Any ideas? Let's start talking about the ways we thought about this pattern. So, did anyone try to count it by ones? We certainly could do that. It might take us a while, right? We could also use our pattern for 5 and skip count, right? Let's go ahead and skip count together and figure out how many dots there are. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's a lot of dots. And we were able to count that in a pretty efficient way. We were accurate, and we were able to do that pretty easily. We could see how many they were using our skip counting. Could we change our skip counting into a number sentence? Let's go ahead and try to record that. So we're going to record that as repeated addition. This means we are going to repeat adding our 5s. So far we have 5 plus 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 5. And how many dots was that again? 50. All right. Equals 50. So how many 5s then are there in 50? We can count to figure them out. Should we count our equal groups of 5 on our dot pattern? Or should we count our 5s on our number sentence? Well, guess what? Both should work. Both should have the same number of 5s. So let's count together to find out. You choose which one you want to look at. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal groups of 5 makes 50. And if we count our dot patterns of 5, there will also be 10. So we used our repeated addition here to make our 50. And 50 is called a multiple of 5. Do you know why? Because to make 50, we can use many or multiple 5s and add them together until we get 50. So now we know it takes 10 equal groups of 5 to make 50. And we've showed it with repeated addition. Can we show this with a multiplication sentence? I think we can. So we can show this same idea using the multiplication sentence of 5 times 10 equals 50. And this multiplication sentence shows us that it takes 10 5s, 10 equal groups of 5 to make 50. Let's go back to our dot pattern again. So, do you notice anything else about our groups of 5? I notice that every one of our groups of 5 has a pair or a match. Here's a pair of 5s. Here's a pair of 5s. Here's another pair of 5s. Another pair of 5s. And one last pair of 5s. So guess what? We have a name for that. And we think about that a lot in second grade. We have an even number of groups of 5 because every group of 5 has a match or a partner. So that makes me think, could we use even bigger groups to figure out how many dots there are? What if we put our pairs of 5s together? If we do that, then we end up with 10s, don't we? Let's see if we can count up our 50 by 10s. So 2 groups of 5 is 10, so we have 10, 20, 30, 40, 50. So this time we counted by 10s, we still ended up with 50 dots, even though we counted in a different way. Let's go ahead and show the way we just skip counted by 10s as repeated addition. We can also show how we put our 5s together. These 2 5s give us a 10. These 2 5s give us a 10, and we're adding them together, right, because it's repeated addition. These 2 5s give us another 10 to add. 2 more 5s give us another. And our last little pair of 5s gives us our last 10. And how many dots do we say there were again? 50. So, how many groups of 10 did it take to make 50 in our repeated addition? 1, 2, 3, 4, 5. So 5 10s will make 50. So 50 is also a multiple of 10 because we can use many 10s, 5 of them, to make 50. So I'm wondering again, could we change our repeated addition into a multiplication sentence to show our thinking? I think we could. We could show this as 10 times 5 equals 50. Here are our 5 tens, 1, 2, 3, 4, 5, and we put them all together, they make 50. So 5 tens gives us 50. That means 50 is also a multiple of 10, isn't it? Because we can add many tens together to get that 50. Let's talk about just one more way that we could figure out how many dots there are here. Do you remember the first pattern we looked at of 4 sets of 5 dots? Do you remember how many there were in those 4 sets of 5? There were 20, weren't there? So I'm wondering, do you see any groups of 20? Do you see any sets of 4 5s up here? Where are they? Well, I see a set of 4 5s here. 1, 2, 3, 4, 5. And I see another set here. 1, 2, 3, 4. Oh, I counted 5 up here. 1, 2, 3, 4. 1, 2, 3, 4. And we know that 4 5s will give us 20, right? So we could combine all 4 of these together to make one big group. So we could add 20 and 20, and then we have a few more to add. How many? 10. Could we show this as an addition sentence? Yes, we could. So we put 2 groups of 10 together to give us our 20. Another 2 groups of 10 together to give us another 20. And then we have left over our 10 in the middle. So we end up with 20 plus 20 gives us 40, and our 10 more gives us 50. Still 50. And this time we thought of a different way to group. Now, can we show this with a multiplication sentence? A little bit, but we had to do some addition too. So here's how we could show what we did here with a little bit of multiplication and a little bit of addition. So we have here 2 20s, 20 times 2, which gives us 40, plus our extra 10 from the middle gives us our 50. So one more way to figure out how many dots. And there's more ways than that too, isn't there? So I thank you, friends, for participating with me today. And we thought about how we can use what we know about numbers and number patterns to think about figuring out how many in ways that are easy for us to see and know, what we might call efficient. And next, we have my friend Miss Gaudette coming up, and maybe you can think about some strategies and ideas we used here to solve some math tasks with Miss Gaudette. Thank you, friends at home, and I hope to see you again soon.
Hello, everyone. So, again, my name is Mrs. Gaudette. Last time we were together, I'd say probably a week or so, we had started on a problem that we didn't finish. So I want to give us an opportunity to finish this problem. I know for sure that this problem now is up on the website. So if you've had a chance, download the problem. And if not, just follow along, have a paper and pencil, and be ready to do some awesome problem solving together. So here is the original problem, and I'm actually going to move it over a teeny bit more so that we can get the next page in. So with this, we had friends you can count on. And we had done a few things last time. We had talked about, we did a modified marking the text for math. It's pretty modified because it's very small what we're doing, but it's enough for what we're trying to do to get the essential information out of the problem. So we had our friends in your class like to exchange stickers. Do you guys like to do that? I know at your age, I love to do it, especially the puffy ones and then the scratch and sniff ones. Do you like a different kind of sticker? Maybe. I know some of you might like the sparkly ones. So you decide to give each classmate 3 stickers. And you have 19 classmates. How many stickers will you need? So we did some math last time. You notice we have the 3 stickers and the 19 classmates. We underlined what are we being asked to do. So we said, how many stickers? So let's just figure that out. In our problem, this is where we started last time. We had our 3 sets of 19 because we're going to give each person 1 sticker 3 times, 19, 19, 19. We added them together to get 57 stickers. And if you remember, Mrs. Sears jumped in last time and said, I thought about that differently. And I really liked the way she did it. She went ahead and jumped in and said 20 and 20 and 20, since 19 is so close. We did 20, 40, 60. But because I had 19, I had 3 extra for each group of 19, each group of 20. So she had to subtract those to get to the 57 stickers. Now, don't forget in your math, you always have to put, what does that number represent? The 57. Some random just 57 doesn't help us, someone trying to read your work, understand what you're doing. But if you put in there a label and label all your numbers of what you're trying to solve, it helps you and it helps other people who are trying to understand your work. So don't forget those labels. Then we moved on to the next one. Your best friend decides to give each classmate 4 stickers. That person, he or she, kind of wanted to really make some friends, really outdo you, right? Nah, they have more stickers, so they wanted to give more out. And we had to find out how many they gave out. So last time we were here, we set that up. We had 19, 19, 19, 19. How many groups of 19 did we have? 4, right? Because we had to give out 4 stickers to each classmate. Yeah, you're right. I heard some people say, well, why did you do 19? I did it because it was efficient and had more. Yes, I could have done groups of 4 19 times. Remember, in problem solving, there's not just one way to solve it. There's many ways. I just chose an efficient way that I liked to use. So let's go ahead and let's look at that. We have 19, 19, 19, and 19. So I have to add 9 4 times. So 9 and 9 make, right, 18. Plus another 9 makes 27. Oh, good one, guys. And another 19 makes 36. Awesome. So I have my 6, I carry my 3. Now remember, I'm going to point this out. I did last time, but I forgot this time. I'm solving this with you on ways I would approach it, me as my individual person. But remember, you always have the opportunity to pause the TV and work on the problem before I start to solve it. Because really, that's probably the best way to do it, or work it out beforehand if you have the opportunity to get to the work off of aps.edu. If you do it first. See if your approach is the same one I used or a different one. See if you got the same answer as me. And if you didn't get the same answer, what should you do? I got the wrong answer. No, never. You look at it and you say, all right, Mrs. Gaudette got 57. Let me figure out, where did I make my mistake? Because remember, we learn more from our mistakes than we get everything correct. Remember, Mrs. Sears has caught several of my mistakes. And that's something like, oh, yeah, you're right, Mrs. Sears. So do the same on your own. If you have that opportunity, please pause and try it before you work it with me. But I'm going to go ahead and continue my way that I would solve it. So I had 36, and then I add my tens. 1, 2, 3, 4, plus 3 is 7, right? What is it? It's 70. So we have 76. If we went to Mrs. Sears' route, she would have said 20, 40, 60, 80. And then I had 4 extra, and I have some people tell me that's the route I would have taken. Because to be honest, this route not always is the most efficient. I'll be honest, I kind of get stuck in a rut and I go this way sometimes. But to do it like 20, 40, 60, 80 is probably a lot more efficient. Minus 4 gets me 76. And 76 what? Right, stickers. All right. So did we answer the last question? How many will your best friend need to give away? Did we answer that? Yes, we did. We had the 76 stickers versus our 57 stickers we handed out. But this one has more problems. Remember, a good problem doesn't just ask you one question. It asks you to build on your thinking. And that's what we have tried to do, is to build on your thinking by giving you some great problem-solving activities. This one is actually from Inside Mathematics. So if you ever have the opportunity, have your parents look at that site. There's many more. But there's just one here that I really liked. So here's our next question. 2 more classmates join in your class. You and your best friend want to give them stickers also. Because, right, we don't want to leave them out. You don't want to be left out, so let's not leave them out. How many total stickers were exchanged? So what is the question that we are trying to solve? How many stickers? I left total out because that's not important, right? I hear you guys yelling at me because total is very important. Like I could just say, yeah, I gave them 4 and 4 for the 2 people and 3 and 3 and just said, I'm done. That's not what it's asking us. It's asking us for the total amount of stickers. So that one, I'm going to go ahead and circle twice so we can know it's not a quantity, but it is something that it is a quantity, I guess you could say, but it's a word that is telling us exactly what we need to do. So I have here my how many total, and then I have to explain. I'm going to underline explain how I figured that out. So it's not just sitting there and doing the work. We also have to have some reasoning through it. So here we go. I'm going to start solving, but that means what are you going to do first? Right? You're going to pause me, try it on your own, and then double check your work. But think about that. How would you approach this? Would I start all over again and do my 19, 19, and 19? Or wait, how many more students would that be? 2 more, right? So would I add 2 more to 19 and then do the same thing, 21, 21, 21? I could. That's actually the way I first approached it. When I went through, because guess what? Yes, Mrs. Gaudette does the math before she does it with you, and she still messes up. But that's okay. It does. It happens. And that's fine, because sometimes just doing it one time doesn't mean we always get it right away. Sometimes we need to do it multiple times. So let's look at that. I need to add 2 more people. What is the most efficient way that I could solve that? Here's my second approach, not my first. My second approach is, well, couldn't I just add on the 2 more amount to the 57 and the 2 more amount to the 76? I could, yeah. That's the way I'm going to approach it, because I think, hey, let's just make it how it is. So let me think. I gave my friends, or you gave your friends, 3 stickers each. So if I added 2 more people in, so I'm going to put this just kind of right here. So if I added 2 more people and each got 3 stickers, how much would that be? So I have my one person gave 3 stickers to, my second person I gave 3 stickers to. So how many did I do? 6. Good. So I'm going to now start circling important information, because now I'm getting all over the place, right? Is this starting to look like it's all over the place? Yeah, it is. So let me circle 57. Let me circle 6. Now, again, I added 2 more people to this amount. So how many stickers did my best friend give out? 4, right? So I have one person, and I have this second new friend in my class. So when I add that together, how much do I have? 8. Awesome. Thank you so much. So I'm going to circle that so that I don't leave that out. So I have 57, 6, 76, and 8. What would I do with that to find the total? I knew it. I knew you guys are following along. So I'm going to write over here. So I have my 57, I have my 6, I have my 76, and I have my 8. Total means, oops, I started to give it away. Yep, means add. So let's go ahead and add that. Whoa. So these aren't easy numbers to add, right? So we have our 7, our 8 is 15. And then I have 6 and 6, which is 12. So I have 12 and 15. So that's, I'm going to just put this here to keep track of this, make sure, hopefully I did this right. 7 and 2 make 7. So that will be my 7 ones. And then my 2 tens. Now I can add up my 7, my 5, and my 2. So if I add 7 and 2, or 5 and 2 make 7, and then I double that, right? 7 and 7 make 14. Did I get you? Or did you catch me? Yep, a few of you caught me. It is not 14, it's 140. So we put that 140 with my 7, and I'm all done. Yay, I'm done. Right, no, you got to give me, what does that mean, that unit mean? 147 what? Stickers. All right. So, explain how you figured it out. Would you be able to explain this? Would you be able to do that, to explain your work and your thought process through that? I might. I could. So let's go ahead and let's look at the next one. It says, your younger brother wants to give some stickers to his classmates. Explain to him how to figure out how many he needs to bring to class. So let's figure out, what are we solving for this one? This one says, right, explain to him how to figure out, right? So if I was to get a new sheet of paper, how would I write that out? How would I explain it? So I would have to, yep, I hear you talking. You got to figure out how many classmates there are, right? Up there it went. Oh, well. So we need to talk, explain. Let's start. So I'm trying to think through it also. So explain. Did I spell that wrong? A-I or I-I-A? A-I, thank you. See, I always have to double check myself too, and that's okay. Explain to my brother to check the number. Yep, I hear you. I'm going to abbreviate. So that's number of classmates he has. So, right, so we found out we had 19 classmates. Then what did we do? Good. So after we figured out the classmates, we figured out then how many stickers we wanted to give them. Next, decide the number of stickers. And then what did we do next? Right? We took that and we took the number of classmates and added it the number of times we want to get our stickers. Add our number of classmates for the number of times. I don't know if it's time or the amount of stickers maybe is a better word. Of stickers. So you might have worded this differently. That's okay. I was thinking on the fly here on this because this is a little different than the way I originally did it. But we said they check the number of classmates, then we decide the number of stickers, and then we add it the number of times. So if we had 20 kids in our class and we want to give them 3 stickers each, we would do 20 plus 20 plus 20. That would help us figure out how many stickers to have. All right, you guys, so this time we had a chance to solve and problem solve through Friends You Can Count On. Next time I see you, we will find out another problem solving task that we can do together. So we will have Miss Obenshane to join us, and she will be doing some fun activities with you on a book and thinking about some math and literature.
Hello, everybody. I am going to just put some new charts up. Just take a second here. And then we are going to read a story. The story that we're going to read today is called Each Orange Had 8 Slices. Let me sit down here. This book, called Each Orange Had 8 Slices, a counting book, is by Paul Giganti, Jr., and pictures were done by Donald Crew. The story was published by Green Willow Books, an imprint of HarperCollins Publishers. My name is Miss Obenshane, and I work for Albuquerque Public Schools, and I'm a Title I math resource teacher, and I'm happy to be here with you today. On my way to the playground, I saw 3 red flowers. Each flower had 6 pretty petals. Each petal had 2 tiny black bugs. How many red flowers were there? How many pretty petals were there? How many tiny black bugs were there in all? On my way to school, I saw 3 little kids. Each kid rode a tricycle. Each tricycle had 3 wheels. How many little kids were there? How many tricycles were there? How many wheels were there in all? On my way to the zoo, I saw 3 waddling ducks. Each duck had 4 baby ducks waddling behind it. Each duck said, quack, quack, quack. How many waddling ducks were there? How many baby ducks were there? How many quack, quacks were there? On my way to Grandma's, I saw 2 fat cows. Each cow had 2 calves. Each calf had 4 skinny legs. How many fat cows were there? How many calves were there? How many legs were there in all? On my way to the circus, I saw 2 colorful clowns. Each clown was holding 1 bunch of balloons in each hand. Each bunch had 5 bright balloons. How many colorful clowns were there? How many bunches of balloons were there? How many bright balloons were there in all? On my way to the freeway, I saw 4 huge trucks. Each truck had 2 long trailers. Each trailer had 4 giant letters. How many huge trucks were there? How many long trailers were there? How many giant letters were there in all? On my way to lunch, I ate 2 juicy oranges. Each orange had 8 slices. Each slice had 2 small seeds. How many juicy oranges were there? How many slices were there? How many seeds were there in all? On my way to the store, I saw 4 trees. Each tree had 3 birds' nests. Each bird nest had 2 spotted eggs. How many trees were there? How many birds' nests were there? How many spotted eggs were there in all? On my way to my friend's house, I bought 3 bags of gumballs. Each bag had 3 small boxes inside. Each box contained 6 gumballs. How many bags of gumballs were there? How many small boxes were there? How many gumballs were there in all? On my way home, I passed 3 yellow houses. Each yellow house had 3 red flower pots. Each flower pot had 5 blue flowers. How many yellow houses were there? How many red flower pots were there? How many blue flowers were there in all? Before my bedtime, I read 2 books. Each book had 10 big pages. Each page had 1 pretty picture. How many books were there? How many big pages were there? How many pretty pictures were there in all? On the last page of the book, I found this poem. As I was going to St. Ives, I met a man with 7 wives. Every wife had 7 sacks. Every sack had 7 cats. Every cat had 7 kittens. Kittens, cats, sacks, and wives. How many were going to St. Ives? That might be a tricky one. We'll come back to that one. We're going to go through a couple of the pages and answer some of the questions that are in this book. If we come back to the petal page, on my way to the playground, I saw 3 red flowers. Each red flower had 6 pretty petals. Each petal had 2 tiny black bugs. How many red flowers were there? Well, let's see. We can count. 1, 2, 3. How many pretty petals were there? There are more pretty petals than there were flowers. Well, we could count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Or we could count by 6s. 6, 12, 18. How many black bugs were there? Well, we could count by ones, but that would be a lot. It was a lot to count our 18 petals. So why don't we try to count by 2s to count our bugs? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. We could write some number sentences to go with this book. This book is a really good book to think about multiplication, kind of like Miss Carnes was talking to you earlier about. We could write our number sentence for the petals in the book. Remember, there were 18 of them. Like 6 plus 6 plus 6 equals 18, because there was 6 petals on each flower. And that would be writing a sentence that matched repeated addition. We could do a multiplication sentence, and we could write it 6 times 3 equals 18. Let's look at the next page, and we're going to talk about our last vocabulary word. On my way to school, I saw 3 kids. Each kid rode a tricycle. Each tricycle had 3 wheels. How many kids were there? 1, 2, 3. How many tricycles? 1, 2, 3. And how many wheels? Well, we could count the wheels by 3 because there are 3 on each tricycle. 3, 6, 9. Another way that we can show the wheels that are on the tricycle is with something called an array. And that's when you arrange counters in rows and columns. So I'm going to do that and show you. And take some of these off here. This would be an array for the tricycles. There are 3 tricycles, and each tricycle has 3 wheels. We could do an array for our petals. We have 6 petals on each flower, and there are 3 rows because there are 3 flowers. So an array is another way that you can show multiplication. We'll try one more, and then Ms. Sears is going to talk to you a little bit more about what multiplication is. This one, you're going to try to make the array after we read the story pages. On my way to the zoo, I saw 3 waddling ducks. Each duck had 4 baby ducks trailing behind. Each duck said quack, quack, quack. How many waddling ducks? 1, 2, 3. How many baby ducks? There were 4 in each group. So 4, 8, 12. Let's see if we can make an array for the 12 baby ducks. I will make it on my chart, and you try to make one on your paper, and let's see if we come up with the same array. Is this the array that you made? We have the groups of baby ducks, and there are 4 in each group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 4, 8, 12. Thank you very much. This book, you can see on our website. We have a link to a video of it that you can watch again. And then what you could do is fill out number sentences to go with each of the pages, just like we started talking about that, and we wrote some number sentences. You could do that activity, and there's a page for that, or you could create your own story page. There's a copy of this that you could print out, but you could also make your own, and just a place for you to draw a picture, and then make your own story about things that you see in your house. This one, my tape is all stuck together, would be about bags of soda. If I have 4 bags of soda, and each bag has 3 bottles. See my picture? 4 bags with 3 bottles. How many bottles do I have in all? See if you can figure that out. 3, 6, 9, 12. 12 bottles in all. So you can go back and watch this story again and create your own pages or figure out your number sentences for each of the problems that are on the pages at another time. Now, Miss Sears is going to talk a little bit more about what multiplication is.
Thank you so much, Miss Openshane. And we'll see you here in just a few minutes because we'll be playing a game. Maybe you can identify that game just from that quick peek you might have gotten really fast on that. All right, so we're going to be talking about multiplication. The first thing that we're going to do is I would like you, if you haven't already made one of these models, this is called a Frere model. You can create one of these at home just on a separate piece of paper if you have one. So what you're going to do is you're going to fold the paper in half. You can say hamburger style if that works for you. And then you're going to do it again. Fold it in half again. So this way you have 4 equal sections. Kind of goes towards some of our ideas that we're working on here. And then on the side that does not have like the open flap, I want you to just kind of dog ear it a little bit on the corner. And that will give you a little space in between, which is where you could be writing the word. Okay? So you could put your multiplication word here or whatever word that you're going to be defining. We're also going to be doing the definition. And I have that written up here. We're going to be doing characteristics about multiplication. We're going to talk about some examples and non-examples of multiplication. And then we're going to show you different ways that you can do multiplication. We've already seen some of that already happening right now. So just so you want to follow along with us, we're going to talk a little bit more about what is our definition of multiplication. Well, as we've already heard, it is the operation of repeated addition. So maybe you've heard that word operation. Now, this isn't the game that you're going to play. It has a little body on it, and you touch the sides of it, and it goes, eh. No, not that kind of operation. This is a mathematical operation. So we're talking about adding, subtracting, multiplying, dividing, okay? So this operation is of repeated addition. And as we've already heard about it, it could involve lots of different ways that you're looking at and seeing the problem. So one of the characteristics that we like to talk about when we're talking about multiplication, let's say I had 2 times 4. We know if that's 2 groups of 4, that X that we see, sometimes we see that X as representing groups. Okay? So we have 2 groups of 4, or 4 plus 4, which is going to equal 8. When I say this 2 and this 4, these are what we call factors. When you multiply 2 factors, you get a product. That's something very unique that you're going to only hear about within multiplication. All right, one other thing that's kind of interesting that you may or may not know about multiplication is if you multiply any number by 1, you get the same number. So if you multiply by 1, any number, you're going to get the same number. What happens if you multiply by 0? You're going to get 0. If you have nothing and you keep adding nothing and nothing and nothing, you still have nothing, okay? So that's something else that's also very unique about multiplication is that when you add, or when you are repeatedly adding nothing or 0, 0 plus 0 plus 0 is still going to be 0, okay? The other thing that we want to talk about here is also the commutative property. And when we're talking about commutative property, so if I had 2 times 4 equals 8, I could also say 4 times 2 is 8. Kind of like what we call a turnaround fact, if you might remember that from your fact families. It's the same numbers. All we're doing is just switching them around, but they'll still result in the same product. All right, so let's talk about some examples. Well, we've got some really great examples already up here. I'm going to actually just take a piece of tape and I'll put one up here. So if you wanted to see an example of how you might see multiplication, you might see 5 times 10 equals 50, as Ms. Karnes already demonstrated for us. What if we wanted to use that any number multiplied by 1? So if I had 10 times 1, what am I going to get? That same number, right? Even if I had 1,000 times 0, what would I have? I'd have 0 because I'd have 1,000 zeros added up, and that's going to give me a 0. So that's an example of something that we might see, maybe a number sentence or an equation that might work with multiplication. A non-example. Well, let's do this. How about 2 plus 4? Well, first of all, we talked about it being repeated addition. Are we adding the same number over and over again? Or that multiple of that number? No, we're not. So this would not be an example of multiplication. What if I had 10 minus 8? Nope, that wouldn't work either. Again, we're talking about repeated addition. We're not talking about subtraction. That might be a different operation that we can explore in a little later. But that 10 minus 8 would not be it. What if you saw this, 3 times 7? But the answer somebody put was 37. No, that wouldn't be correct, because that number, all we did was just put the 3 and the 7 together to think it was 37. We didn't maybe draw a picture of it or show how we could represent it to be able to know how to do that correctly. 3 times 7 is actually 21, because if you did 7 plus 7 plus 7. All right, so there are a couple of different ways to show this. One of the ways, as we've already talked about, is repeated addition. So I'm going to go ahead and just write that one really quick. That's just adding the number over and over and over again, like 2 plus 2 plus 2 plus 2. That's going to be 8, right? We can do an array. That's the second way. And as Ms. Obenshain was explaining, so that would be like if I had 2 groups of 4, so maybe I had 2, I'm starting with those groups in the rows in the column of 4, I would have 8 altogether. Remember that commutative property that we did? So if I did 4 rows of 2, all I'm doing is really turning that array on its side, and that would be to show that 2 times 4, or 4 times 2. That's that one. Okay, there's one other last way, and I think we talked about it. This was about skip counting by those multiples. Okay, so if we're skip counting by multiples, we're just kind of counting really fast over those numbers and talking about the different multiples that might be there. So if we're thinking about that, we might say 2, what's counting more by 2? 2 plus 2 more would be 4, 6, 8. On that fourth multiple, when we've skip counted 2 4 times, we would have 8. Those are just some ways that you might be thinking about how to do repeated addition. Now, really quickly before we have run out of time, I wanted to kind of just do a quick game with you guys. And I think you can probably recognize what this game is just by looking at it. You guys may notice this as maybe the hashtag symbol that you might see. You might also think of this as a number sign. So one of the games that we wanted to play today, and this is just really quickly, I'm going to have Ms. Obenshain come back up, is tic-tac-toe. But this is a variation of tic-tac-toe. What we're going to do is we're going to actually just try to do equation tic-tac-toe like 3 in a row. Okay, so I have created some equations, and just to let you know, we do have this up on our website if you needed to do this, and we're going to basically just solve some of these problems really fast. And I think we're probably going to have to come back to this on our next session, because I do believe we are running out of time. So I do have a couple of other games to show you. They are going to be up on the website that you can look for, and when we come back, we can play these games, and I'll show you a couple of different ways on how to do those tic-tac-toes. I want to thank Ms. Karnas for coming in and talking to us with her dot talk this morning. I also wanted to make sure that we thanked Ms. Gaudette for her problem of the month and Ms. Obenshane for reading that wonderful story. We're going to come back and we're going to have fun with playing some games next time. And thank you for joining us today with At Home at APS. Have a good day. Thanks, mathematicians.